No, Postman, it's actually, there's two ways. One, it's actually a Chrome extension.
Yeah.
There's also a desktop app for it. We'd recommend you download the desktop app. Yeah. Okay, yeah, let me just send you the link for this thing. Postman, download. There'll be an option to use Postman on the web. We'd recommend you not do that. Just use the desktop app for Postman. You don't need anything else today besides just Postman and VS Code. If you haven't installed Visual Studio Code, then you have to give you the link for this. But I'm presuming most of you already have VS Code installed from the past 2 days.
Okay, guys, I think I'll start now. So welcome to day 3 of JS Week. Today we'll be introducing Node.Js and Express. So hopefully by the end of today's session, you'll be able to build a very, very cool Node.js application. Before we actually dive into how to build a Node.js application, let's take a brief look of what is Node.js first. So Node.js is a backend JavaScript runtime environment that executes JavaScript code without a web browser. So normally, most of you already know what is JavaScript. So basically, Node.js is essentially taking JavaScript and running it without the web browser. So it's also open source and cross-platform, and it's the industry level of how you would write APIs nowadays. So for today, we'll actually start. We're actually using a framework called Express.js on top of Node.js to easily build REST APIs. Well, don't be afraid. I just spit out a lot of buzzwords like REST APIs and Express.js. So don't freak out first. We'll be looking into that one by one now. So we'll start with what is REST. So REST is a shorthand of saying representational state transfer. RESTful API is an architectural style for an application program interface known as API that uses HTTP requests to access and use data. And REST API is based on the client-server paradigm. What does that mean? That means that the server does not need to know who the client is or how he works. They interact through tokens and sessions. This one later, Sid will talk about it. And mainly, REST API is used for crowd applications. So crowd is a shorthand of saying create, read, update, and delete. So create data, read data, update, and delete data. So how do you actually use crowd application? So we use HTTP verbs to define our requests. So you can put get, post, put, delete on your request, and on your backend side, it would see that it's a get request. Then that means read data. Post means create data. Put essentially is update, and delete is delete. So REST API works on endpoints. So everything is built on endpoints. So endpoint is basically just a URL of it. Users of the API call endpoints to with HTTP verbs like get, post, put, delete to perform crowd applications. So a really, really good example of an endpoint you can directly use is this. So JSON placeholder.typicode.com You guys can check this out. So this is basically an endpoint that user can interact with. So as I state here, is actually the browser is requesting a GET request through this URL. This is basically endpoint, and then on your server side, you will read that, oh, this is a GET request. So the server will go and read data and then give back a list of data. This is a really, really good example of that. As you can see, this is also built in Express. So that's what is REST. And now, so this is a basic diagram on how the client will work with server. So server, you can think of it as the Node.Js and Express, and client will be your browser. So the first thing is client is using a login request, talk to server, and then passing anything like username, passwords, and then on the server side, you catch what the client sends in, and then they'll on the industry level will be going to the database and then find whether you have a match of passwords and usernames, and then if that match, give back something. So in this case, assign JWT. So JWT is what I said just now is the tokens. So the server doesn't know who is the client, but we're using tokens to identify what client, who client we are working with. So JWT is industrial level of tokens used. Essentially, it's just a string with a lot of characters, and then it's saying that it's basically like a token, and then after that you can the client will store the token for future requests to the server. That way the server will know that the client is actually authenticated. So yeah, this one. So the second one is like after your login request, the client has the JWT token already. So client can actually ask data requests with JWT token. That way server will know that client is actually authenticated. Then it will give back some response. So this is like the gist of it, of how modern application works. So we talk about a lot of buzzwords like Express and then Node, and then we say like it's the industrial level of what people use. So there's actually a lot of companies that are using this. So LinkedIn, Twitter, Netflix, even NASA is using Node. So it's a really a mature framework or architecture to use. So today's agenda will take in like why use Node. We'll cover that. How to get started, we'll be doing that a bit later. And then afterwards, Siddharth will, I'll pass this on to Siddharth, and Siddharth will share on how you could actually build a simple API with Node and Express on top of Node. So just now we talk about REST APIs, we talk about Node.js, and then we said that we're going to use Express on top of Node, right? So what is Express? Express is basically a wrapper that around Node.js to simplify the process of building APIs. So you can think of it as a library, some sort. It comes with a lot of pre-built components, a lot of functionality out of the box that you can use to write REST APIs. And this is also the industrial level framework to use on top of Node.js to build APIs. So now, do you guys have any questions? Anything I missed out? You guys have any question? If you have any, why? If you don't have any questions, press N. Okay, nice. So without further ado, I think we have basically run through all of this to introduction of what is Node Express. So now, without further ado, let's hop into how to actually set up the Node environment. So in the Finder or whatever you have, if Windows, then Windows Explorer. Now I will go into a folder called JS Week, and then we'll create a new folder here. So I'll name it as JS Week Node.js. So what I will do here is to open a terminal on this folder. So on you can use your favorite terminal. Mine, I'm using Item, and on Windows you can use CMD and stuff. So to start with this, we actually need npm. npm is a node package manager. I'm sure you already have that if you followed our previous tutorial. So you should have your npm ready already. So to start off with a node environment, you have to type npm init. Init basically means initiation lah. So npm init to start with your Node.js application. So enter. So what npm init will do is he will go through a walkthrough, and it will create package.json file. It's a funny file. So later I'll explain it a little bit. Basically, package.json will have your details of what you're building, the dependency, development dependency, and all those cool stuff. Basically, now we are walking through on how npm will set up your package.json. So package name, JS with Node, press enter to skip, and then version 1.0, you can skip this. Okay, description, you can put like fancy words here. So you can put like this is my first Node.js application. Press enter, entry point, index.js, that's fine. Catch comment, you can just skip it first. I need it right now. Git repository, you can actually put a Git repo name here for future use cases, but now I don't have a Git repo set up for this yet, so you can just skip this first. Keywords, you can also skip this first, but you can actually put in like Node.js, Express, those kind of things. Author, this one will be your name, so I'm gonna put in my name. You can put in your name too. The ISC is the license for it. So after that, you'll see a summarized version of what you have entered, and then you see just now I put in Node.js Express as the keywords and description also. If you're okay with this summary, press enter, and it will create a package.json file. So anyone stuck with anything? All good? If you have any problems, then press N, and then if you're okay, then press Y. All right, nice. All right, seems nobody has any issues. So so just now we have run, just a quick summary, we have run npm init, and you put in a lot of details inside and creates a package.json. So in order to start working with Node.js, you have to have a text editor that will actually show your file system, and then you will edit files and then create files and so. So if you have Visual Studio Code installed, you could just you could just type in code and then followed by a dot. You open your VSC instance, or if you don't have that, open your VSC, and you could file and open a workspace. So Anyone has an issue with opening VSC? All right, so if you have opened your VSC, you should see on your file tree structure. Normally, it will be on left side, on your left side, but I did some customization to be on the right side. But as just now said that npm will create a file called package.json following by your a lot of your details you just put in. So you'll see the exact same thing just now. So I have the keywords, yes, express, and then this is all pre-built scripts that you can use. And the version, the name, description, and main is like the entry point. Now you can run through. Main field is a primary entry point to your program, and then your author, and then your license. So so now that you have your basic Node.js environment set up already, I'll pass this to Siddharth, where he'll introduce you on how to install Express. And hopefully at the end of this session, you'll be able to build a working REST API Node.js application. So, stop
okay. Second, screen one. Okay, first of all, just want to cover one thing before we start with the API. So yesterday, if you would have recalled, I think Sean walked you through how to set up the front end for this recipe app we're building. The thing is, where does the backend come into play in this big picture? So, example, let's say the app stores all the recipes inside a location or maybe database. So then the front end will ask the backend, I want all the recipes, give it to me. So then the backend will send it back. It'll send back a huge list saying that these are all the recipes in the system. The front end will grab the data from the backend and print it on the front end. So let's say now the front end decides to, okay, fine, my user, the guy using me, he wants to add a new recipe. Then the front end will say, okay, fine, I have a new recipe for you to add to the system. So the front end makes a post request. This time it adds new data. It sends a post request to the backend. The backend takes this new recipe, stores it somewhere, and then it says, okay, fine, I added successfully. You can do the same for deleting a recipe. You can update an existing recipe. You can get a particular recipe by an ID. So basically, you can interact with the data source through the backend using a bunch of requests. So as Sean mentioned just now, since the front end and the backend are completely separate, the front end is hosted separately and the backend is hosted separately. So these two guys, they don't know about each other at all. So when they're communicating, the backend needs to know which user is asking for something. For example, when the front end, when the guy logs in there, it's going to send to the backend and with the email and the password or whatever credentials. And the backend will say, okay, fine, I know who you are. This is your email. Keep this token I generate for you. So every time you come back to me to ask for something, you give me this token also. So I can just decode this token and I know who you are already, instead of you having to log in every single time. So this is a way to ensure authentication in API. Make sure that all requests that come to have some sort of security so you know who's actually making the request. We won't be enforcing authentication today, but this is a general flow of how the front end and the back end talk together, and they know who each other are because they're hosted separately. Okay, so now let's, any questions about this, the structure, or can we go to the code straight? Y for yes, Y for got questions, and for no questions. No questions. Okay, let's go. So Sean walked you through until here. I'm just going to open my VS Code window. Okay, so he walked you to package.json. All good. Okay, so now I want everyone to go to your terminals right now, the terminals where you installed this thing, installed the node repository, and then I want you to type in npm install global nodemon. Just copy this command for you. Yeah, Sean put it there. So why do we use nodemon? Because every time we are editing our files, when we save the thing, we want the server to update automatically. We don't want to actually restart the server every time we change something small in development time. So nodemon, every time it detects a change in what we're typing and we save the file, the nodemon will restart the server automatically, so it makes it easier to test, which is why we'll be using nodemon to run our code. Okay, so assuming you have nodemon installed, all you need to do, considering you're in this repository, you go ahead and make an index.js file. Index.js, and then you should have two files in your repo right now. You should have an index.js file and an automatically generated package.json. If you have this current setup, Y for yes and for no. Okay, so you have two files right now. Good. Okay, now, so this is the very start of an application. Let's install the first package we'll be using today, and it's already in the title of the workshop. We need Express.js. Express is a wrapper around Node because raw Node.js is a bit difficult to work with natively. So we'll be using Express. So go to your terminal and type npm install Express. It should be pretty fast. And okay, so Node.1's still running. npm install Express, okay, install that. And after that's done, if you go to your node modules folder, you would see this a lot of junk here already, because right now we have our first dependency, which is Express. And Express has its own dependencies. For example, this package itself depends on other packages inside this library, so it installs its own. So as soon as you install one package, your node modules folder just blows up at it. So assuming you have this, let's go ahead and set up our app. In index.js, go ahead and type const express equal to require express. So what does require do? In Node.js, whenever we want to import a package, we use require. And if you let's say we don't type anything inside here, and then we let autocomplete, we can see all the packages that this repository has. For example, fs is for file system, so you can read files and write files natively done. Express, the one we installed just now. We have Node.js clustering, we have buffer, HTTP, which is the native, it's a native module. OS, we can do like system commands using OS, and a bunch of others we can check out later. But for now, we'll be importing Express. So this variable now, contains a reference to Express, which is the package we'll be using for today. Let's go ahead and create the app. Since Express is just a package, we need to initialize it. I'm going to create another variable. I'm going to call it app. Const app is equal to Express. So I'm going to call it a function. You hover over it, then you can see it creates an Express application. The Express function is a top-level function exported by the Express module. Just typing in const app is equal to Express, calling the method will initialize an app for you right now. And all we need to do after this is say app.listen, and I'm going to tell it what port number to listen on. So I'm going to use, 3000, and I'm going to pass in a function after this. So it will print out on the terminal right here what port we're currently listening on. So I'm going to say console.log, I am listening on port 3000. So in an API that's hosted on the cloud, this particular application will be running 24/7. So it'll be constantly listening for different requests coming to it. So since we already have our initial setup, just go to your terminal and type nodemon index.js. And then you should see there, I am listening on port 3000. If you don't see any errors so far, which means that your Express is set up correctly, your node modules are in the right place, and we are good to go. Y for yes, N for no. Do you guys see I am listening on port 3000? Okay. Okay, a lot of yeses there. Nice. Okay, so let's actually call this API in some way or another. So as Sean mentioned just now, there are a few ways we can call an API. I mean, there are a few methods we use. First is get. Get is to grab resources. We use post to create resources. We use put to update resources. And we use delete to delete resources. So autopilot does that for me. And as you see, every time I save this file, it automatically restarts the entire server, which is why NodeMod is amazing. So there'll be get requests, post requests, put requests, and delete requests. These are the major HTTP verbs. So let's say we want to listen for a get request. So I would do something like app.listen. No, not listen, sorry, app.get. So if you do a dot, and you can see all the methods we have. You have get, we have post, we have delete, we have put, we have patch, a whole bunch of HTTP verbs are. Today we'll only be focusing on get and post because these are the two major ones in the HTTP ecosystem. So we'll first do an app.get. App.get. The first parameter here is the route. So I'm just going to call it the initial route, the slash. So this is the first thing. Whenever you call the API without any extensions, it'll be hitting this route. So I could say I'm going to pass in a callback after this. And this callback takes in two parameters, request and response. And it opens up a callback function in Node.js. The request is the data coming in. So Node.js gives you a reference to the data coming into the request. And the response is what you're sending back. So let's say you want to send something back. I would do something like response. This again. Yeah, response.send. Response.send. And I'm going to say, welcome to my API. So we get the, so as soon as you know the API is ready, and you just call the initial endpoint, the data that should be sent back at this point is going to be welcome to my API. How to test this? Let's actually go ahead and test this. Open up Postman. Open up Postman. If you have localhost 3000 ready here, so just open a new tab. Make sure it's a get request. You can have a bunch of different requests, but make sure it's a get request. This get is the standard one. HTTP localhost 3000 because we are running on 3000, and just type send. We should see welcome to my API. Y for yes, N for no. Does this work so far? Yes. Only one person. You must have lost that. Okay. No, not yet. Okay. Sean will help you out with the. This is the code. Let me just put this here. Oh, with Postman. Okay. Open up Postman. Open up let's open up a fresh instance actually so I can show you how to Postman. Then Postman will boot up. No, you don't need to. You can just open up any fresh tab. Just open a new tab. Don't need a new workspace. You can create a new workspace if you wanna, but it's just a matter of calling the API somewhere. Just make a new tab and just type in http:/localhost 3000. That's it. HTTP localhost 3000 and just send the request. The server will be able to, yeah, as Sean said, don't use HTTPS because our API is not secured yet. So if you use HTTPS, it actually should not go to, I think, or it won't go to because it doesn't exist securely. HTTP, yeah. Nice. Okay, let's go ahead. So since we're already getting our first route, we know our API is working, the core is set up. let's go ahead and write something useful. For example, let's say we have a, I don't know, get the name. So let's say we have an object in the database, and this person is going to be me. I'm going to call it me, okay? And this API, we're going to write an API that's going to send back details about me. So name is going to be and we are going to send back this, gender is going to be male. I'm going to send, I have an interest list, let's say interests, and I'm going to give a list here, and I'm going to call it reading, snorkeling, and Netflix and chill. So 3 interests there. You can create any object you wish, I guess. This is our static data store. There's no database. I'm going to simulate a database here. So name, gender, interest. For example, I could even, my ID. For example, my ID. I'm going to give it a random ID, and yeah. So let's say this is a user object, and this API is going to send back details about me. So I could say this API could get a request saying app.get, give me your name, /name. So if I want to get a request that says /name, we want to send back request response. Okay. That's response. And in here, I'm going to send back response.send me.name. So if the server gets a request that says give me your name, then I'm going to give it the name. So that's the very fundamentals of how an API works. I ask for something, the API gives it back to me. In this case, I'm going to ask for the name, and it's going to send me back the name. Let's go and try that. Let's go to our Postman, and let's say /name, and it should send me back my name. You can even format this nicely and say something like, write a nice JavaScript string and says that my name is, and send me back the name from the data store here. So run the request again, and you will get a nice string saying my name is Siddharth. Y for yes, N for no. So far, everything okay? Okay, got back our first resource. Okay, nice. Okay, nice. We could do the same thing for gender and interest, so ID or whatever it is. That's completely fine. Let's just do one more for maybe app.post, no, app.get or app.get, and do a /gender. And I'm going to say request response. I'm going to say request response.send, and I'm going to send back my gender is, and do a me.gender. And if you send a request to /gender, you'd get back your gender. So it's pretty simple there so far. Okay, now what if I don't want, just I want to send something to the API first. So for example, let's say I want to get my second interest. I don't want all my interests. I only want my second. I only want to get back snorkeling. So how do I pass in data to the API? How do I send data to the API saying that I only want this detail? I'm telling the API a very specific detail about something. So we could do something like app.get /interest. But this time I want to get a specific interest or a specific position of an interest. So I go to something like app.interest /ID. And let's do the same request response. So what I'm allowing the API to do is I'm allowing the user to send back a particular ID of an interest. So they could actually tell me which element of this interest list to index into. So I could actually access this particular variable inside my body. So to access this, we just have to type in console.log. I have to log it out the console, request dot params. Params is the parameter. So whatever we put after the colon here, so /:ID, we can access it in the params object. It's automatically done. So request of params.id will tell the API that this is the ID of the interest that the user is asking for. Let's say we go to our terminal our Postman, and type interest slash I don't know 3. It won't send back anything yet, but if you go to our terminal here, we can see that it's asking for index number 3. So what we have to do is just have to send back the interest of at this particular index. So I just do something like response send the interest at position vector.params.id. I will say request.params.id is, and then I just send back the me.interests rec.params, so request.params.id. So response.send, the interest at position, at particular position I send, is me.interest request.params.id. So there's only 3 interests here. It's like index 0, 1, 2. Let's send index 1 perhaps. And so this, because I won't run, send, and it should by right send. Oh, I didn't save the file, sorry. That's why. So interest at position 1 is not going. Let's say I want my interest at position 2. My interest at position 2 is Netflix and chill. Interest at position 0 will be reading. Okay, so we could even do some simple authentication here, like if or we could store the variable here. We could say something like ret index is equal to the request.params.id, and we could do some basic checking here. So if the index here is smaller than or equal to 2, no. We just have to pass in the the parameter that comes after it. So 0, 1, and 2 to index into the list here. That's just an example of the user sending data to the API. So if index is smaller than or equal to 2, then go ahead and do this, because the list only has 3 here. But if the user gives me some kind of invalid value there, like 1000, then response dot status, I could send back status like 400, and then say send. This was a bad request. Or you could send back an error message. This is not a valid index. If the index is a valid number, like 0, 1, or 2, we even authenticate further and say greater than 0. 0, 1, and 2, send it back. If it's something crazy like 1000 or an invalid number, then send back an error code of status 400 and say this is not a valid index. This is a bad request. I can't send you anything. Let's try that out. Let's try it as a request with like some weird number, and it's going to send back this is not a valid index because I don't have the data to send back to the API. This is a very, very simple way of doing some checking, at the backend level. Who's with me so far? Why for yes and for no? How to get parameters from the user. Okay, nice. Okay, for example, let's say I have like another field here, and I'm going to call it my secret word. The secret word is like top secret one. I cannot tell anyone. Line 27. Oh, you mean this particular thing? Let me just give you the entire request. Yeah, okay. So let's say I have a secret word here, and I'm going to say my secret word is, I don't know, keep it simple, Milo. And this particular secret word, like only people with a certain authentication can access this. Like it's like top secret. I cannot give this to anyone. What if I want to make sure that this particular API route is like only people with a particular passcode can go ahead and access this thing. If people have the wrong password or these people I don't trust, I won't give them the secret word. In this case, we use a concept called middleware. So let's write our first middleware function. It's just a standard JavaScript function that's written the same way as a request and response. So it is something like authentication. And I'm going to say request, response. And this time, there's a third parameter called next. I just wanted to join. Third parameter called next. I'll explain what next does in a bit. It's pretty interesting. So let's say this particular authentication is like, if the authentication, if the request dot body, this time let's use the body, if the request dot body dot password is equal to, it's not password, let's have like a special password now. 1 2 3 4 5 6 7 8 9. So if this is the password, then sure, this guy is the correct, he can access the resource, he can access the top secret resource. But if no, then we can just type, okay, I'll explain. If no, then this guy is a scammer, he's trying to hack my API, I don't want to give him any resources. So in this case, what happened? Okay, yeah, in this case, I would send back saying that, no, this is, you're not authenticated. I would say something like response dot send invalid password. See, it does that for you. You even put a status there. Okay, Sean, what's the status code for invalid password? 400. 100 or wait, 4 is not found. I think 400 or 400. You guys can check out the HTTP status codes later. Just Google this HTTP status codes 200, 400, 404, 500. Okay, so if the thing is correct, then okay, fine, give him the resource. If not, just send back this invalid password. So let's actually write that out for this here. App.get top secret word, and let's do the request response there. And so here, how to authenticate? All I need to do is pass this authentication in between this list of functions. So in between getting the request and handling it, I want to do something in between. I want to check 403, okay. So in between getting the request and doing something with it, okay, I want to go ahead and check first and do some middleware checking. If this function says it's okay, then go ahead and move on to the next one. If not, stop the user straight away, send back an error because the password is wrong. So I could do something, I put the authentication in between. So the first parameter is the top secret word with the route name. Second parameter is the first piece of middleware for the checking. And the third parameter is the one that actually handles the request. The one that actually handles the request and sends back something to the user. So if the password is correct, then just have to type next. So what this third parameter does is it passes over control to the next piece of the middleware. So the next function in this chain here is going to be the request response, which is the handler. So if all is good, then pass it on. If not, say no, guys, stop here. This you're not authenticated, you cannot access this resource, send it back straight away. So if everything's okay, then pass it on. If not, send back invalid password. So then, when they've reached this route at the end, we already assume that they are completely authenticated already. Now I just have to send back response.send, and I could say me.secret word, because now they've already reached a certain security authentication. And just to prove to you that we actually reached this route, I'm not actually lying about this. Let's see console log here, request.body.password. Now if we call the route top secret word, okay, without any authentication. So let's do top secret word. And this time it's a get request. It's a get request. Without any authentication, send it. Oh, sorry. Wait, let's send back a bad password. Your form encoded, and then just say password. And this is going to be an submitting password of undefined, submitting request body, request response. Okay. What did I do wrong?
I think you have to use right top params, right?
Hey, it's inside the body. What?
Inside the body.
It's form data. Okay, what's going on? Suppose your password is this, then send it back. If not, send invalid password. A. Or is it because it's not hitting the, yeah? Hang on. Why is it saying it's undefined? First response next. Okay, I just tested this one. Once again. Response section, request or body. The request object even exists. Yeah, request exists, but for some reason. Oh, sorry. It's the get request. There is no body. Yeah, we need to change this to a body. Changes the post request. Forgot about this. Sorry. So top secret request will be actually a post request and authentication. So here's another thing I forgot about this. All only post requests can handle body. So you want to send data to the body, you have to have it as a post request. Get request can only accept parameters. So now if we do this as a post request, everything should work. Or even now, what is going on? Okay. Go to the password. I don't know what's going on. This body, password, top secret word, authentication. Okay. Sorry. App.use express.json. We forgot to do this at the start. I'll explain why. We'll just make sure it fixes it. Actually, sir. Oh, express.json. Okay, yeah, I got it. Okay, yeah. At the start, I missed a step. So express.json, what it does is it makes sure that it's another middleware that makes sure that we can access the body as a JSON object inside any of the requests we make. So we need to have this middleware at the start. I missed this at the start. So yeah, app.use express.json should allow us access to what's in the body of the request. So now if we send a request with an invalid password here, it should by right say invalid password. And if we give it the correct password, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, even now it's invalid. Why? So looking at this, body the password is, why is it undefined? Now I'm maybe confused. Wait. It's not causing the error anymore, but it's saying it's undefined. No, it's not because this thing. The password itself is coming as undefined. Yes, I can. So JSON. Sean, am I missing something? I missed something. The password is this, then next. Why is it? It's a post request, right? Form data. No, it's not because of form data. I'm sending it to. Either one also didn't work. It's still undefined. So the body itself is not. an empty object. Wonder why. Tested this because the body parser is not working anymore. Wait, sorry, wait a second. I think it's because of body parser. Sorry about this. I don't know what happened. That is deprecated. And still it's undefined.
Hey, stuff.
Hmm.
You try looking at the Google Meet chat.
What's happening? Oh, you can. Wait. No, you should be able to send to here. I tested just now, it worked. If you send it as a raw JSON, it should also work. For example, you send it as a here is a password. Oh no, this one. Password is technically if you send it, but the reason we have this middleware is for it to automatically pass the form data into JSON. Produce. Express.json should work on this. That's the thing. We use express.json and remove the body parser, and then you check the header to make sure it's sending it as JSON. Okay, I'll check on this later during the break. By right, you should be able to send it using form data and form inquiry. I don't know why Postman's causing an issue today. Okay, let's move on for now. We'll come back to this in a bit. So essentially, you'll be able to check whether this particular person is authenticated by passing in the correct password. If not, then it will send back saying it's an invalid password. So this is the first level of middleware checking. To prove that the middleware runs in a chain, we could even do something like I run first and I run second and this is the last one. So app.get chain would have I run first, this runs goes first, then another middleware here, and finally we get the final handler. So this could do something like rest.writeHit, response.writeHit, and you could say I come first, like H1, I come first, and then response.writeHit, H2, I run second, and then it could do a final response.writeHit. Oh, wait. Let's say do, okay, response.writeHit. Maybe do a H3, I run last. And you just have to pass it on to the next. So you just write it. So write, and then you finally do a response.send. So if we call this request, we call the /chain, we're gonna see both of these running first. So we do a slash chain. We're gonna get request. So we get the first one adds the ICOM first. The second middleware gives I1 second. The last middleware calls I1 last. And let's say you're authenticating a user in one of these middlewares. You can even set a variable here to the request object. So request dot, for example, the user ID is gonna be 123. You can access this request ID in the final. So I could do something like the request ID is request user ID. So even though this is a totally different function, the request object will be passed on to the next one every time next is called. So this is sort of persistent. So let's say you're logging in a user, you can grab the user data from the database and store it inside a property in the request object. And then a later bit of the middleware can access this property. So if we run this chain again, the request ID is 123. Even though this particular variable was set in a different function, it is passed on in the chain of middleware functions. And this particular chain can go on and on. I mean, this could be an unlimited list of different functions you want to run in between. You can authenticate, you can validate. So usually in a server, that would be something like the request name, which is like slash chain. Then we want to check whether it's authentication. We want to check its validation. Validation is to make sure that the correct fields are given, and then finally send back data. So each one could be its own middleware function. Send back data to the client. Okay. Anyone have any questions so far? Besides that weird express.json thing, I'll debug this in a bit. Any questions? Why for yes and for no? No questions so far. Okay, let's go on a 5-minute break. I'm just gonna have a look at this thing. 5 minutes or why that didn't work just now. So now it's 9:02. Can we come back at 9:07? 9:07, maybe we can go drink a glass of water or something. Sure, okay. Okay, I'll copy my code, yeah. I'll put in the paste bin in a bit, yeah. Okay. Yeah. Okay, yeah, let's get back to it. Okay, is everyone back? Okay, yeah, let's get back to it. Okay, the reason just now it didn't work was I missed one very important line. Because we're sending from Postman, there's multiple ways to send data, and one of it's form URL encoded. We need to tell Express to look at this particular field. We need to say express.url encoded extended is true. So only if it looks for this URL encoded field, it'll be able to pass it to JSON. So now if we send a request in, using just for URL encoded, it should work. And if we do a wrong password, then it will be an invalid password there. So this is an extra line you should be adding to make sure that Postman can read Express can read what's coming from Postman. If you're doing this from the browser instead of Postman, it'll all be fine. But since we're doing this from Postman, we also have to tell Express that we have to go and look there for the JSON object. If not, it won't work. So that was the reason. Sorry for the delay there. Yeah, okay. So whenever we're sending it from Postman, don't forget to tell Express to look over there for the data. It's a very Postman specific thing, but you have to add URL encoded there. I forgot about this. Okay, let's go ahead and continue. So what we've covered so far. We've covered what routes are, or what are get routes and post routes. So let's actually apply this in our scenario with recipes, what we were discussing that day. Yesterday with the recipe front end. Let's actually build the back end for it. Let's clear what we have so far. Let's clear everything but this authentication. Let's move it to the end. Move the object also to the end. Let's clear our sort of console here. Okay, dump it out of sight. And we just have this. So welcome to my API. Let's call it something else like welcome to the recipes API. So we're going to store our recipes here. So the first thing we do when writing an API is decide what kind of routes we want. So I'm going to write a few. I'm going to write my first route, which is to get all the recipes. This will give me all the recipes, send back all the recipes. Next route I want to do is get, but this time I want to get a particular recipe by its ID in the database, by its ID. Send back a recipe. Oh yeah, autopilot does that. With the ID, yeah. Then I want to do a post request / post. I'm going to do a post recipe. This time I want to create a new recipe, add a new recipe. And let's say I have so we're going to have get. We're going to have get all the recipes, get a recipe by its ID, and we're going to create a new recipe. We can create a delete route later. So let's just do these three. So let's create the first route. Get all the recipes. So app.get / recipes, and write our request response here. And in this case, I would have to do response.sendback all recipes, but we don't have this object yet, so let me create that for you. Okay, so let's create our recipes object up here. Response recipe is going to be a list, and this list, we'll just copy it over. I'll give it a paste bin. So I'll just give this in a bit. Okay, so there's a bunch of recipes here. So it's a list of objects. So the first one is recipe number 1, recipe number 2, recipe number 3, and recipe number 4. So each one has an ID, the name of the recipe, or dessert in this case, and the instructions, which is another list. So we have 4 here. So the first one, which gets back all the recipes, app.get recipes, is going to send back everything. So if we actually open up our changes to a get request and call all the recipes, we should be able to get back all data as JSON. So this is actually a JSON object, and this can be passed easily in the front end. to send back the recipes. Oh yeah, it's a keep the doubles. So yeah, it's one single. It's not the list of lists that was causing an issue. Yeah, so we get back a list of all the recipes. Simple. So now let's get back. The next route is first route is done. Get all the recipes. Next one, get a recipe by a particular ID. So in this case, we have to go and search. Let's do some simple JavaScript to search. So app.get/recipe with a particular ID, of this particular ID. Then we will do something like request response. And yeah, also to wrap this up. So yeah, so you can call it direct or you can call it full request and response. Let's just call it request and response. So we would do something like that ID, the ID that's coming in from the front end is request.params.id, and the chosen recipe is going to be recipes.find. Let's do a find. If you came on, I think yesterday, there was a link shared about different JavaScript list methods. So find is one of them. That's what a callback. So recipe. So only send back the recipe whose ID is equal to the ID that the user sent. So this will basically this .find function will send back the first recipe in this list that meets the condition, and the condition is the ID of it should meet the ID of the one that the user is asking for. Then just send it back. Response.send to send it back a chosen recipe. So we would just do something like let's say we want cake recipe /1. Recipe times ID recipe dot. What's happening now? I'm calling the right route. Route. Defined y undefined recipe. Because it's a string. A second. Okay, sorry, it was a string just now. Sorry, we wrote the code for this a while back, and our things are okay. So the thing is, whenever it comes in, by default it's a string, but in the list we store it as a number, so we have to pass it to an integer. So we take the string and pass it to an integer, and we grab the particular ID. So then if we move to console logs, so we get the ID, we pass it to a string, pass it to an integer, compare with the list here, and send back the first one that matches the criteria. So if we send it, we get back this one. Let's say we send with the ID of 2, we get back the recipe with the ID of 2. And this will be pretty useful for the front end. Now let's go ahead and do a post. Let's create a new recipe. In this case, we want to pass in the data of the new recipe inside the body of the request. So request response, as usual. And this time, let's grab a few details we need. So we want to create a new recipe. We want to have the ID of the recipe, which we automatically generate. We want the name of the recipe, and we want some instructions, which is a list. So we will do something like let the ID is going to be automatically generated. So this could be based on the rent of the recipe, so the rent -1. So we get the ID of the last recipe currently, and we increment that by 1. So that's the new recipe's ID. The name will come from the request.body.name, and at instructions, it will come from request.body.instructions, which will assume it to be a lister. Let's create a new recipe. Since our new recipe is an object, new recipe, it's going to be ID. It's going to be ID. The name of the recipe is going to, the dessert name here in this case. Dessert name is going to be name. And the instructions are going to be the instructions that the user gives us. And let's add this to our data store, recipes.push, new recipe. And let's send it back to the front end. Response.send, new recipe. What's happening here? We automatically generate the ID based on the existing recipes. We grab the name for the new recipe. We grab the instructions from the request body. We create it, we push it to our internal data store, and then we send back newly created recipe. Let's go ahead and try that. Postman has one limitation in the sense that we can't actually write JSON here. So in this case, we have to go and write it inside inside raw. So we need to pass in the name. Let's create a new recipe called, I don't know, is that pudding already? Pudding already exists. Scone also exists. Muffins, cake. Blondies. Let's do blondies then. And the instructions would be a list. In this case, it would be a list. So, I don't know. Mix the flour and put it in the oven. I really don't know how it's done. Put it in the oven. Don't save it this time. This time will be a post/recipe. This time, what happens is it sends back to the backend as a JSON file itself, and then it creates the recipe and sends it back to the front end. So now, when the application is still running, let's say we want to get back all the recipes, just send back a GET request, get all the recipes, and this time we would see a new entry here, which is the one we just added. So we were able to get a recipe by its ID, be able to get all the recipes, and we are able to create a new recipe. That's a very, very simple code application or something. Okay, so now let's write the one last route, which is deleting a recipe. Okay, let's do that. This the code. Okay, so in this case, we just have to go ahead and write a delete route for this. Able to get a post. Let's do perhaps a delete. Delete. And in this case, we also do the recipe /recipe/ID. And let's get the request response. So the ID we want to delete again is request params.id. And we just need to delete it from the list. So that would just be recipes.splice. Splice, right? So we just need to delete the one at this index. And we just send back the recipes. Check. Or actually, a simple way of doing this would just be the recipe. We, instead of using a splice, we'll do what to handle the error case. The new recipes list would be recipes.filter, which is the filter method recipe, where this recipe's ID, recipes.id, recipe.id is not equal pass int and we just send back the newest recipes. So in this case, we grab the parameter, which is the index that the recipe we want to remove. We pass it to an integer, and we use the list. We index it from the list. So let's just do a delete route. So this will be a recipe slash sp1. Oh, it's a constant right now. Let's make it. Okay, so in this case, we send it back, and then the recipe with the ID of 1 is now deleted from the list that we get back from the data from the backend. So we're able to create a recipe, we're able to read recipes, and we're able to delete recipes, and update pretty much works the same way. So we have these fundamental routes set up. Okay, so this is basically a code application. We're able to create resources, we're able to read resources, update resources, and delete resources. And usually the data that we store is not going to be just stored in a list inside the file itself. It's usually going to be on a database. And then the particular routes will call database operations to create, read, update, and delete the resources that we have. Yep, create, read, update, and delete. Okay, after this, we are going to be talking about the final bit, which is routers. How we're going to separate the app, how to modularize our code instead of putting all the routes into one file. So right now, let's say our application is going to be a designer application. So application is going to have two things. One is to do with the users, adding and deleting users. And another one is to add and delete recipes. So these are totally different parts of the application, and we want to put our code for this in different places. And this is where express routers come in. Express routers. Okay, who's with me so far? I mean, anyone confused, or did I confuse anyone accidentally? Y for yes if you're okay, and N if you're confused. Why okay? Okay, a few people are okay. Everyone else how? Okay. Okay, let's set up our routers. So we have a users route and we have a recipes route, and each one has its own get, post, and delete requests. So let's create our first router, which is for users. So const user, so I'll call user router. Our user router is going to be express dot router, and const recipe router is going to be express dot router. So what we could tell the application is, if app.get, if you get something that starts with user, then tell them to use this router. I'll just put it at the start. So if you get something that starts with user, I use the user router. If you get something that starts with recipe router, so I say app.use recipe, then you go ahead and use the recipe router. Yeah. So then we just need to define the routes for the recipe router. So this could be something like recipe router dot get slash, then go ahead and do this. If recipe router gets all the recipes, then go and send it back. If you only want a recipe router, and post the recipe. So in this case, we could probably move all the recipe routes into a different file. Let's go ahead and do that. Let's create a new file and let's call it recipe.route.js. So recipe route, and then we just copy in everything from the router. Copy the router inside here, and we copy all our recipe specific routes inside there. It will cause a few errors there now. So in this application, we only left with, let's move this there also. Let's actually minimize this and keep it. So we have the recipe router all sitting here, and the recipe router is defined here. We just need to export this out so the main function, main file can use it. So we do module that exports. So the exports is we're gonna send back. We're gonna export out the recipe router, and to use it, we just need to import the recipe router from here. So import recipe router from the next file. Recipe router. Okay, this is an export default then. Using posting outside the module, then shoot. Why would this be a easy to import express here? And it's all running fine. So we import the router from this particular folder, recipe router. And then, so all the routes that come to, that start with /recipe, we're going to use the recipe router to handle it. So we do a /recipe /recipes. We do get all the recipes. It's going to send back everything. So any request that starts the recipe, what Express does is it delegates it to this particular router, and then the router handles all the work. So you get to clean up your code a bit. We could also write another route, and we're going to call it user.route.js. And all the user-specific routes like creating, logging in a user could all be this as a specific router. So this really keeps your main file, which is this particular index.js file, keeps it really clean, only for importing middleware and setting up the routers. So you can really modularize your application using Express routers there. We've covered all the fundamental concepts of Node.js, including code and middleware and routers. Middleware is often a bit confusing. So there's a question there maybe you guys can ask. Other than this, let's just move this to the other file. And this particular module is done because recipe router is ready. Just to explain a bit more about why we do the app.use. So all the stuff we define at the start for .use, it will run before any of the routes are run. So for example, let's say we're doing express.json or express.url encoded. What it does is express.json, it takes the request body and then it converts it from JSON to a JavaScript object. So then we can go ahead and do request.body and pass the object. If we don't do this, then we get the error just now. We can't actually read what's in the body of the request. So we need these two middlewares every single time. Or, I mean, if you're not using Postman, just at least express.json, because it tells Express to go and look inside the body of the request and convert it to a JS object. So when your application goes, you will have a lot of middleware here. You would have a logger middleware to print out all the errors in the console. You would have a middleware to read the env files. So the list of middlewares will just go and go. So that becomes a very important concept when it comes to Express.js. And when you're setting up a database connection, everything is automatically done inside the index.js file. So you would do all the middlewares here, then you would connect your database, which we'll do tomorrow or day after, actually, day after. Connect the database, and then after that, after everything is set up, all the middleware is ready, only after that is your server ready to start handling requests coming in. So in a real API, when you're dealing with databases, instead of just updating your internal data store, what it's going to do is it's going to go to the database and update the values in the database. So in order for that to happen, the database has to be connected and set up first. That's the fundamental concept there. And so once we are done with most of the code, we can go ahead and edit our script file to add a start script. The start script is going to be node index.js. And let's say we're doing a development or dev, we can say node.mon index.js. So in the node index.js does not restart the changes. If you're doing a development, then you can use node.mon. So instead of doing node.mon index.js, just do something like npm run dev, and automatically runs node.mon. But if you're already in production and you just want to start up the server, just type npm start, and this just runs node index.js. So you can write a bunch of scripts here you can use later in order to optimize your flow. And if you're looking for packages to use in your application, you can check out npm.js, npm, which is you can get a bunch of libraries here. For example, React is a library sitting inside npm.js. We have Vue. We have, for example, you want to work with datetime, we use Moment. And then you can read the documentation. And if you want to install the package, just copy the command here and go to your repository and just type in npm moment, and it will be installed. If you want to import it, it's just a matter of doing a const moment is equal to require. And if you scroll down and see, you will see a new dependency here called moment. Yeah, and you can start using your application. So npm is like managed by thousands of developers. So there's literally a package for everything. You want to do something, it's probably a package for it already. So you don't need to write your own code to do a lot of like standard stuff. And Moment.js is very popular for passing date and time. So they have very good documentation also. You can see how to use date time with Moment. See how to import it, how to use it, read the docs, and just you can play around with it. Everything in npm is a package. So you can install any package you want, and whenever you install it, it'll be added to your package.json file. Okay, in terms of content, that's actually it. Are there any questions so far? I mean, any confusions, middleware, packages? How the API is connected together? Okay, no. So let's say that the thing is running at localhost 3000 or whatever port. Then in order to call it from the front end, which is just a matter of you go to your new Chrome tab, then you do a localhost 3000 / recipes. Oh, it's not running, sorry. Recipes /recipes, sorry. And you'd be getting a nice JSON object in your browser. So if your front end calls this data, your front end can acquire this particular JSON list and show it in a nice way. So it prints it out nicely. Every request that your browser makes is a GET request automatically. And if you want to make a POST request, you have to use either a HTTP library or a tool like Postman to test your POST requests. But any GET request that you write, you can automatically use your browser to test, because your browser natively makes GET requests. Yeah. Any questions? Anything you want to cover? Anything else? Or okay then. No questions. Okay. The only bit that's pending, which I didn't want to cover today, but since we have time, we can actually touch on it, is looking at a bunch of off libraries. So let's wait for 5 minutes for a few questions first, then we'll continue. Just a few minute break. Okay, let's just discuss the last part of the day, which is how to handle auth and handling secrets in your application. So whenever you're connecting to database, you would have to have maybe a secret connection string, or you're connecting to another API. You probably have a secret that you don't want to expose. So I want to talk to you about environment variables. What is environment variables? And how to import them. So it's just a matter of making a file called .env, and then you could write your secret here, super secret, and then I could write my password.
You're not sharing your screen.
Oh, sorry. Yeah, so environment variables. So super secret could be a big number here, something. And then this particular thing, you can't expose it inside your source code. So you're going to have to put this inside a file that you don't push to Git. And an .env file is automatically not pushed to GitHub. So if you want to access the variables or secrets you put inside here, you need to use a library called npm inst.env. And we need to run a middleware here to import it. So we do a require, let's create this one. So require .env .config. So this would basically just look for an env file inside your main directory, and you can access stuff using process.env. So let's say you have a default route, that's that app.get. Now you have an app.get here, and then you do want to send back something, like send back a request response. And you could just send back the response.send, and you can do a process.env, then you can call your super secret. So let's say you have a database connection string or whatever, then you can make a, what's not running. So we can get back the thing from the secrets. So whenever you're pushing to GitHub, make sure it's not pushed. You can make a git ignore and make sure your env file is not pushed. All your secrets could be here. So when you're reading documentation for APIs, they tell you what kind of stuff to populate inside your env, and this really secures your API keys and confidential stuff. When it comes to the content for today, what we planned on discussing, that's actually it. We moved pretty fast, so we're kind of done already. There is one more library we want to discuss. That's for Friday. It's called Passport.js. Let me just put it here. Since we're done already, I want to ask, do you guys want to continue with this, or do you want to wait on this until our final project on Friday? Because this is an interesting library we use for authentication. Okay, I think everyone's tired. We'll do this on Friday then, along with the big project. That's actually it for today. If you have any questions, you guys can stay back and ask. Or thank you for coming. And we will see you tomorrow to learn about databases, specifically Postgres. And all the code will be posted, all the stuff done today will be posted on GitHub and shared with you.